Every time I forget about the microphone. Good morning, everyone. The worst part is when I'm muted, I fix it quite quick, but then 10 seconds later I get a stream of messages from you in the chat being like, "You're muted! Panic!" So no, it's fine. Good morning. Welcome to the second day of term. And I hope you've had a great first day. It's been a while since I've seen you. I can't believe that we have two lectures that are 20 hours apart from finish to start, but we do. And I guess it's exciting because we get to get through kind of like a whole lot of content for the week. I think this is the first time that I basically had the first two lectures before your classes, which is exciting because like today, for instance, we can actually go through Python a little bit, which will kind of get you more comfortable with the lab and probably part of the project as well. So let's get stuck into it in a sec. I think just some general reminders. So probably, it feels like there's a lot of technology sometimes. I think that's just the nature of online learning. But just to remind you all, so like WebCMS3 is where let me put this on a bigger editor. WebCMS3, just as a reminder, is kind of where pretty much your like base of everything is. And then the kind of other key tools that matter are like we use Zoom for tutorials and labs, we use Collaborate for help sessions. So this one isn't super critical. We use EdStem for the forum, and we use GitLab for like all your work, and we use Teams for your major project communication, which we'll talk a little bit about at the end of the lecture. But this kind of feels like a lot, but it's not really. Like if you actually go to a normal course, they usually have a forum and a place they host code, even if it's just another website. But I know it kind of feels like sprawl right now for you, for some people, no doubt. But yeah, this is kind of it. This is like the crux of it. Most of you will be concerned with GitLab. It'll be like a major thing. That's kind of where you'll spend most of your time, just on WebCMS3 and GitLab. I'll say it again because I always get the same students kind of ask the questions. I think because of 1511 using Collaborate. So tell me if this makes sense. Collaborate is generally a worse tool than Zoom. The one benefit of Collaborate, though, is that you can. There's kind of the one benefit of Collaborate is that you can move breakout rooms around a lot easier, right? In terms of like if you want to run like a help session where you just have 7 rooms and students can move between them, or like 3 or 4 tutors can move between them, then it's a much better tool. Unless you need it for that, generally it's preferred to use something like Zoom or Teams because it's a little bit more reliable and there's other benefits to it. So that's why we use Zoom. And in general, it's kind of like you want to use Zoom unless you need something for Collaborate, which we do for help sessions, right? Because sometimes help sessions have like 2 or maybe 3 tutors on them, which you just can't do with Zoom. So hopefully that makes sense. But I mean, it's not too hard these days. Like these tools, you don't need to install anything. You just log on and use it. Yeah, okay, let's get stuck into Python because we'll talk a bit more about the project later on, right? So this lecture today, for those watching live, is Python, testing with Python, and then a little bit on the major project. So, great. Okay, let's get stuck into Python. For many of you, this might be the second programming language that you're learning, which is kind of exciting, right? Like a number of you, probably the majority realistically, have only come here knowing C or maybe some of that MIP stuff or whatever evil things they teach you in 1521. And Python, as I said yesterday, is a higher level language. And what that means is that if you wanted to do something in C, like if I said to you, I want you to make something in C, I want you to make a program that reads in some names from standard input and then adds them all together and outputs a giant string. When I say a higher level language, what I mean is that to do something like that in C, you might need, 20 lines of code. Might take you 15 minutes. Like a competent person might take them 15 minutes. Python, it might take you 5 lines of code and take you a few minutes. And that's because Python does more for you. And these high-level languages like Python tend to be slower as well. So there's this natural trade-off in everything in computing where the more easy to use a language is, the more a programming language helps you so that you don't have to baby it. The easier it is to code and the slower it is to run. So that's pretty normal. Now, one big difference with Python in particular, before we even get into the syntax, is that and you've done this with C, you know with C that when you have some source code, that you have to first compile the source code with GCC, and then you compile the source code to machine code. That's that binary file that doesn't have a file extension that you tend to run with the // and then you run that machine code, and it actually just runs it for you, right? So GCC is about turning text or source code into machine capable code, and then you can take that machine capable code and run it as many times as you like. Python, on the other hand, is a little bit different in the sense that it does the compilation and running in one step. So when you run a Python program, it's like the GCC part and the running part are all tied together, and it's just, here's my source code, run it. We often call these languages interpreted languages as opposed to compiled languages, which is like C. So C being a compiled language, Python being an interpreted language. And there are some kind of subtle differences between interpretation and compilation, but to oversimplify it again, interpreted languages just compile and run at the same time. They don't quite do that because sometimes they don't actually compile the whole file at once. They just compile what they need. Q asks a good question, which is, does Python still compile to machine code at some stage? Yes, everything has to compile to machine code because the only thing that can execute our code is machines, funnily enough. So it's kind of like C. When you compile C, you're essentially compiling it to assembly form instructions. Because and again, I know a number of you have done 1521. It's like your computer CPU has a set of instructions, right? They call it the instruction set, and they're all the things it can do. It can add, it can remove, it can multiply, it can jump and do everything else. And all compilers are things that take text, because that's all a programming language is, right? It's a text file. Just because you put a .c out the front of it, or you put a .py out the front of it, it doesn't really change what it is. So if I have a Python file here, and I'll open like start.py, let me just open that properly. And, and I say print hello, this is just a text file. It's just characters, right? It's just a whole bunch of chars. And all the Python interpreter does is that when I say Python interpreter, I mean like the Python command which compiles and runs it. So all it does is read that text and convert it to machine code to then run. Because all of this stuff needs to fundamentally be reduced to a set of instructions in that instruction set. Because, a CPU, like an Intel CPU, there is no print command on the Intel CPU. And you can, if you're really bored, and I know very little about this x86 instruction set, like you can Google this stuff and you can be like, oh, I wonder what all the instructions are on all these different CPUs. And this is not my area of expertise, but, yeah. Anyway, my point is that whether it's Python or it's C, these languages still actually need to reduce everything down to these kinds of basic commands. And this is very 1521 stuff, computer engineering, electrical engineering to an extent as well. So you can check that out. Okay, so one other thing about Python is that unlike C, in C, it's often very much like you kind of have to reinvent the wheel a lot in terms of like when you do it at uni, it's like we're going to write some libraries that do things that we've done before, like using, make your own linked list library. But in Python, for many of you, it'll be the first time that you've used a language that is heavy on libraries, right? So Java, Python, JavaScript, I'm trying to think of other key ones people learn at uni. They're probably like some of the main ones. They have a lot of libraries. So if you remember in C, when you were writing the code, you would include, like, you'd hash include stdio.h or standardlib.h or math.h. These are libraries, but typically you would only use a few in C because you'd be writing a lot. So in this course, you're going to be importing a lot of libraries because you don't want to reinvent the wheel. Other people have already written linked list libraries for you. Other people have already written, for those that do 2521, they've written searching libraries for you. You're probably not going to write ones better than them, so there's no point trying to reinvent them. Because of this, I just want to flag at the start, some students, again, inevitably feel a little bit scared when we learn Python because they think that we don't teach enough of it in terms of they're like, there's so much to Python and I need more help, or like, this is a library we haven't covered in the course. So maybe you need to solve a problem, so you Google it and you find something that we haven't taught in the course, maybe a certain library, like a, I don't know, like a time library or something. And you're like, oh God, you know, like this, I didn't learn about this. And I think this is actually like there's actually a point I want to emphasize, is that these languages like Python are just huge, right? There's many different ways to do things. There's tons of libraries. So unlike a course like 1511, you'll have to get very used to being taught the basics by us, because we don't have a whole year to teach you everything. And then you will have to do a lot more self-learning in terms of Googling, basically, how to solve problems. So we'll help you write basic Python programs, but you'll often come across, be like, oh, I wish I knew how to do, how do I make all my letters in a string lowercase? Or like, how do I see if a particular substring is in my string? You know, there's like 1,000 different things you might want to do. And just researching it yourself is totally normal. It's like learning any language. In fact, this is actually why I've become quite a strong advocate of teaching C in 1511. There's kind of this different, this is a quick tangent, different opinions you see floating around CSE and the staff, where like some people think, you know, C's a really bad first language because it's so complicated. And then other people say, oh, you know, we should be teaching Python, or we should be teaching, you know, like Java or something like higher level, so that first years aren't really like hit hard with, you know, pointers and all this stuff. And I think the general argument for people that think C is a good first language is that it's low level and it's important to learn the fundamentals of computers. I, at this point in my life, don't really think that's a great argument, because like, why not learn assembly then? Why not learn, you know, raw instruction? Like, why not do 1521 first? If that's really the purpose of it, why not do 1521 first? Because that's even more fundamental. I think what is great about C is that the language is actually dead simple. Like, if you go back and you think about 1511, like, what can you do with C? You're like, okay, well, like loops, if statements, structs, pointers, functions, data types. Like, you could actually learn C in a day if you really wanted to, right? Like, the whole language is quite small. And that's actually where something like Python differs. And I think an important psychological jump to have in your head is that in Python, you'll find solving problems to be a lot easier than C, but the breadth of the language will be huge. You won't feel like you've like in C, you're like, I get C now, I just don't know how to solve this problem. Whereas in Python, you're going to feel like it takes you quite a long time to get a good breadth on Python, because there's just a lot to it. Okay, so how do we run Python code? Well, there's kind of 3 different ways. Well, I guess 2 main different ways to run it. Not that this matters too much. This is the standard way that people would write it, which is like, you have a file. It can be a .py file. You could name it anything. It doesn't need to be .py. You could call it hello.hayden, and I could put print hello Hayden in here, and I could still run that, right? If I just run python hello.hayden, it's still, oops, okay, yep, it still works. The file extensions are just pretty, you know, don't mean that much on computers, but that's all I have to do. I just write some Python code and I just run python start.py. Now, as someone asked before about is this compiling and then running it? It's like, yeah, so this is like the GCC, GCC start.py and /start in C speak. Both of these things are happening at once here when you run it. So, yeah, Python start.py. I can also like write Python, if I do, it's like Python, is it Python C? Python C, I can do some weird things like this with Python, where instead of running a file, I just actually give it the code itself to run. That's sometimes useful. Maybe we'll come back to some examples about that later, because that can be quite useful. But let's get into some bigger syntax things. So I've actually got all this code sitting on a lecture, on a repo, which you can see if you go to lectures, and then you go to this bit here, code used in lectures. This is actually our where all the code for lectures is kept. This repo is always subject to change. It's in this giant content repo, but you can clone this if you want. Just like on your own machine or whatever, you just git clone, hit enter. It'll take a while, I think, because it's all the content in the course. Apparently we don't teach much. So inside of content, lecture code, week 1, now we start to find some of these examples that we have here. Amin, yes, the answer is yes. I kind of answered that before, so I won't elaborate on it. So let's have a look at our basic file, basics1.py. Now I'm going to open this up in Sublime. I could also open this up in VS Code. I like Sublime, I'm sorry. I work with it every day. Maybe I have a soft spot for it that's completely irrational. But I don't even know why I did that. I can should just open all the files. Click the wrong button. Now I'm downloading something. I actually mainly like this because I'm used to lecturing on smaller screens before COVID, and I like Sublime because it was a tiny editor. I really hated coding on those chunky editors like VS Code and Eclipse, because like if you're trying to explain something to students, it just like consumes the whole screen. So it's probably just a habit. You can actually change the name of the folder you clone to. So for instance, if I go back here and I go to clone this again, if you give it a 4th argument, it's actually the name of the file. So like, who asked that question? Taylor. So if I just do git clone and then the repo and then space Taylor, by default it will clone it into a folder called content. But now if I give it the name Taylor, it'll clone it into a folder called Taylor. And now you see that I have these 2 folders, content and Taylor, that are both the same git repo. But I'm going to go back into lecture code week 1. VS Code's great. I do use VS Code at work sometimes more and more now. I don't think there's anything wrong with it. I think it's a great tool. It's pretty lightweight in the scheme of things too. So MS Word is the best IDE. I tried to do my very first programming on Microsoft Word, actually, making web pages. But the funniest thing, so I used to try and write like HTML on, in Microsoft Word, and I would try and just write it in Word and save it as an HTML file. But one of the funniest things that I never realized Word does, which really just screws with any programming, and some of you might have found this out, is in Microsoft Word, you actually have these like the double apostrophes are different. So if you try and write double apostrophe in Word by default, have a look at the difference here. If I just write like p style equals color, notice how that they're not actually double apostrophes, and most compilers will be like, what in God's name is that strange slanted symbol? So anyway, that's a life lesson for everyone. Some people on the chat have messaged about Pycharm. So Pycharm is I believe it's a JetBrains. Yep. So JetBrains is I don't know, Czech company, Chechen company. And they make a bunch of different editors, and these editors tend to be quite specific to the language. So something like VS Code is kind of meant to be this very, universal thing. Like you use VS Code to write a bunch of different languages. Pycharm, though, is one of JetBrains' tools, which they have a few of them. I don't know where they're listed. Developer tools? Yeah, IDE. So they've got like PHP Storm for PHP, for Go, for C or C++, for Ruby, WebStorm. I have no idea what WebStorm's for. JavaScript, of course, it's for JavaScript. And these things are fine. If you want to poke around with them, you can as well. So they're totally sweet. I don't use JetBrains stuff very much, but I hear people like it. I'm getting a lot of questions on the chat about editors, so I'd maybe just touch briefly on that. So you've kind of got, I guess you've got three different tiers of editors. You've got things like gedit, which are super retro, and probably they're really fine for this course, at least in the first few weeks. So it's only really bad, I think, at a larger scale. Gedit's like the most basic thing. Then you've got some editors like Sublime and Atom. These things are basically lightweight. They're like a they're friendlier to use and they're much nicer to use, but they don't have the heaviness of the other editors, because the other editors have syntax checking and easy, like some more advanced features, right? So the more features an editor has, the chunkier it is, the more screen space it takes up, the more RAM it uses, the slower it is, etc. And they're all trade-offs, right? Like gedit's obviously faster than this. Then we have code. So if in a folder on the CSE machines you type in code and press dot, you'll bring up Visual Studio Code with all of your code, and you can develop it in here. And VS Code has a bunch of stuff built into it, like a terminal. So for instance, if I would like to just run all of this in a single terminal, then here it all is, and I can just run it here. This is why I say most students will probably want to use what would you call it? VS Code. It's usually just pretty easy. I like it. Pycharm. So Pycharm, the other one I mentioned, is like VS Code, except it's an editor quite specific for Python. So I haven't used it extensively. Yeah. I like to teach some of this stuff very basically, because I'm trying to get the fundamentals of this stuff across. So the less distraction I have, the better. Now, let's just quickly talk about Python version, because that came up, and I'm just trying to find out where it is. So Python versions, there's two key Python versions, which is Python 2 and Python 3. Now, Python 2 is quite old. I don't know how old it is, but there's like Python 2.1, 2.2, 2.3, and then there's Python 3.1, 3.2, 3.3, etc. And Python 2 is kind of a legacy tool. Many operating systems like Ubuntu, Linux, still rely on them to run, as in it uses Python 2 libraries. But Python 3 is probably like a much more common, if not universal, development tool. It basically has some extra features. So, I mean, these ones aren't super exciting, but there's some subtle syntax and logic behavior differences. So you can see Python 2 floors decimals and integer operations like C does. Python 3 doesn't. Python 3 has brackets around the print function for consistency. There's a lot of subtle differences. So I think when you're Googling how to solve problems, you generally will want to... generally might want to be aware of what Python version you're doing, because sometimes you'll Google a problem like, how to find a substring in Python. And I know we haven't gotten into the language much, but you go to some Stack Overflow thing, and sometimes they'll be specific. I don't really have an example here. But sometimes you'll see in Stack Overflows, they'll be like, if you're doing Python 2, then you should do this. And if you're doing Python 3, then you should do that. So that's something that you should just be very wary of, is the differences between those two things. Now, someone asked, what version of Python are we using on CSE? That's a great question. So if I do Python -- version, most Unix commands you can do a -- version on, like GCC, that's the GCC version. Git has a version. So I can find the Python version. And what you'll see is that the default CSE Python version is actually 2.7. And this is kind of the old school legacy Python version, which is like, this is the one that's like backwards compatible, like 15 years or something. If you install Python on your own machine, it's very likely that the version you have when you do that. In fact, let me show you. If I open my Ubuntu editor, terminal, sorry, at home, and I do Python version, I don't know what this will be. That's the same one. Depending on what you install and how you install it, it will be a different version. So the thing is that in this course, we use, I think it's Python. So in this course, we use Python 3. And if you want to run code with Python 3, right, you, instead of writing Python, you just write Python 3. And it's now the Python 3 interpreter. So if I want to run my, hello.hayden, I just use Python 3 instead of Python 2. Now, what version of Python 3 does CSE use? 3.7.3. They update these things all the time, so I do lose some track of it. But from what I understand, generally speaking, like 7, 8, or 9 should be fine. And when I say those different versions should be fine, most of you don't need to worry about that because you can just run Python 3 on the CSE machine or something. But if you have Python 3.8, that should be fine. I think the only thing to be careful of is don't run Python 3.6. I don't know what version like I have on my own local machine, for instance, but I might check Python 3 version 3.8. So you can see that my local machine is slightly further ahead than CSE's default. Now that's not a problem because Python 3 broadly is roughly the same. These version differences are not that dramatic compared to Python 2. Just make sure whatever you're doing, you're actually developing on Python 3. So when we run code in this course, we're actually going to run Python 3 and then the code. So for instance, the file's in this folder here, python 3 basics1.py. So let's run our first Python file together. Now, this Python file is quite straightforward. Let's look at the key aspects of the language though, which is a little bit different from C. The first thing you'll notice is that when I declare and define variables, I don't need to give it a type. That's because Python is a loosely typed language. So I can say name equals giraffe, age equals 18, height equals 2048.11, num equals something, and num2 equals something. And I don't even need to like call it an int or a char star or anything of the sort. So Python is a loosely typed language. And what that means is that the Python interpreter tries to figure out what you're writing for you. So it's not like, hey, I need explicit instructions. It's like, you tell, I'll figure it out. When it sees something like giraffe, it's like, well, that's probably a string, right? So I've just commented out some code here, which, speaking of comments, in Python, there's kind of two main ways to comment. In C, you have your double slash for single lines, and you have your, slash stars for blocks. In Python, it's kind of similar, except instead of a double slash, you have a hash, and instead of a slash star, you actually do 2 lots of 3 apostrophes. So that's how I've commented out this block of code here. And if I wanted to comment out a couple of lines, I could do that there. Okay, great. Now I can print things in Python. I can print name, I can print age, I can print height, and we can see what these things are. Giraffe 18.2048.11. Loosely typed languages can be cool because it's less code, it's less that you can screw up, and you can do some other things. Like if I want to, I could concatenate strings together. Giraffe is cool, like this. I could just join 2 strings together by adding them together, like that. So Sarth asks, yeah, Python declares the data type itself. Yes, Python, as it's interpreting your code, it's making its best guess. Sometimes weird things happen. Let me show you an example, right? So like let's see what happens if I say name number or something equals name plus 2. Right? So name is a string, probably, and 2 is a number. So let's see what Python does. It complains. That makes a lot of sense. Let's see what happens. Maybe I can write it up here, Python plus 2. See if we just print name. Sometimes Python's smart enough to be like, yo, I can't really concatenate these things because they're different. Sometimes weird things will happen though. In this case, you're okay, which is super useful. Other languages, like loosely typed languages, have very strange side effects of this. Python is smart enough to say, hey, I've interpreted that this is a data type string and that this is a data type int. See how it says cannot concatenate, what is it? Cannot concatenate string not int to string. Very confusing description. But loosely typed languages, very interesting stuff. All the basic operations that exist in, plus, minus, divide, times that exist in C exist here. There's a couple of extra operations. So if you have a look here, we've got num1 and num2. Does anyone have any idea what these two star operations and slash operations do? Now, like this, the reason I kind of emphasize this is because it's good to actually, sometimes you'll see things like this, and you're just gonna have to Google them, and we'll Google them together. But so you write on the first one that star in Python is to the power of. So this is 3 to the power of 3. So if I did this, then that's 3 to the power of 4. And if we do // let's see, what is double slash in Python? Right? And then we go to, where's this end us up on? Python has 2 division operators, a single / character for classic division, and a double / for floor division, rounds to the nearest whole number. Okay, so let's have a contrast as to what that is. If I have 26 divided by 3, what is 26 divided by 3 going to give us? It's going to give us what, like 8.666 or something? Yep. And if I do 26 / 3, what am I going to get? 8. So it's basically like 26 divided by 3 is, funnily enough, kind of like 26 / 3 is, funnily enough, the same as 26 divided by 3 in C, because in C, if you have an integer divisor and an integer, whatever the hell the top one, numerator, I don't know what the top one's called, then you get it rounds down, right? It floors it. So same kind of thing here, except obviously this would work with decimals as well. So this will still floor it for you, I think, unless that divides perfectly, which I don't think it does. Yep. Cool. So some subtle differences there. There's more to that. That's just like simple stuff. But the point is, it's all kind of the same. Now let's get to printing, which I think is a really critical part of Python because it's very different from C. Remember, in C, if you want to print name and age, you'll do something like this. You'll say my name is string and my age is D, and then you'll get name age like that. That's a C way of printing. In Python, there are a handful of different ways to print stuff, but let's focus on 3 of them. So the first one is concatenation. And what concatenation is this is a concept where you basically join strings together. So I've got a name here, I've got a string literal here, I've got my age, I've got another string literal here, and I've got another variable here that I've converted to a string. So let's just focus on commenting out these lines. Let's just focus on this name string whatever thing. Okay, giraffe 18 2048.11. You can see it's printed out the name, it's printed out the comma space, it's printed out the age 18, it's printed out another comma space, and it's printed out a height. Okay, so a couple of things here. One is that you'll notice that the use of single apostrophes and double apostrophes is interchangeable. That's kind of useful. So if you use single or double apostrophes, they're both okay in this case. Another thing you'll notice is that if I'm concatenating a string to a non-string, like say this text to age, I actually need to explicitly cast it to a string here, right? So like why that's important is, if you just say I want to print my name plus a comma, it'll just print your name plus a comma. But the second you add a non-string type, it's now like, hey, you need to explicitly tell me this is a string because I, Python, don't feel comfortable enough converting this for you, just assuming that that's what you want. So that's how we can print out a line. The other way we can print things out in Python is, I mean, this one isn't as common, but print can take in many arguments, and it will just print them all out, like name, age, and height, like this. So if I just do this to start, like print name, comma, age, comma, height, you can see that it actually just prints them out with spaces between them, which is the default behavior. And then this is where like the interaction with Python gets a little bit different from C, in the sense that sometimes Python functions actually can take these like trailing parameters, in this case like sep, which means separator, and you can specify to it that you want the separator to be a comma space. And what that means is that instead of putting a space between each variable here, it's actually just going to put a comma between them, right? Another couple of things you notice about Python. One is that there's no semicolons at the end of the line of code. That's because a huge part of Python is that it's white space sensitive. And what that means is that Python sees a new line and therefore it knows that you have a new command. We'll talk more about white space sensitivity in Python soon, but yeah, Python is white space sensitive, which is really critical, so there's no need for semicolons. And then the other thing about Python is you notice that we don't actually have to put a \n here. So if, you know, normally you might think, oh, I need to put a \n, so I've got my name, age, height, and the new line. I run this again and I get a new line. And the reason is because the print command in Python by default puts a new line at the end of your string. So when you print in Python, you get a new line at the end of the string. Common question people have, how do I stop that happening? Because there are some times when you want to not print a new line at the end of the string. The answer to that is that on the print command, you can actually give it another trailing parameter, which is end. And the end property by default is a new line, right? Like every print command at the end of the line puts a new line there for you, but you can actually specify something else. So I could say, I could just make my print statement end with Hayden. And you see that new line's gone because I've replaced it. It's by default a new line, but I've replaced it with that. No, you can still use \n. It's just, that's still valid. It's just that it's kind of, the Python print command has a built-in, it has a default property for the end of it, which is \n. And if you don't specify it, it will just default to that. And then the third way to print, which is kind of the way we'd recommend it, is using this concept called f strings, which is I think it's new as of Python 7 or 6. I think it might be Python 7. F strings. This is an example of one of those random things that are Python 3.6. Okay, so it's not super new. Now the way f strings work is that if I just have a string like this, right? Double apostrophes, and then I've got some random things with braces in between it. And I print it, it just prints out the string, literally. Because everything in Python that's between two quotes is just a string. If I put an F outside of my string, my double apostrophe string, then what this does is this signals to Python, right, that this is a, what do they call it? Does F stand for something? I've never actually looked. I don't know. Mysteries. So what this F out the front says is, hey, if you see any braces inside my string, can you please assume that that is like a variable or something to process, right? So if you see braces inside my string, don't just print them out literally. Look inside them and try and calculate what's inside them for me. So if I was to say copy these two lines of code and run them like this, then you can see the first line I get name, age, and height, and the second line I get giraffe 18 and 2048 because Python now interpreted what's between those braces. Yeah, I'm sure that F stands for formatted or format or something. I just wasn't certain. So yeah, that's kind of the crux of it here. You can do a ton of things with this, like you can do 0.2 and it will, well, I mean, obviously that's going to just print 0.2, but you could do like 0.2 plus 0.3. See, VLab's lagging on me here. Sorry, give it a sec. VLab, I love VLab. I love VLab. It's so fast and reliable. Ah, beautiful. So you can see there that it doesn't have to be a variable name. My point is not that f strings allow you to print variables in between the braces. The point is that f strings allow you to execute code basically in between those braces. So it doesn't need to be a variable. It could be 0.2 plus 0.3. But yeah, they're the kind of key ways to print. Now, the last few things to print here I just want to show you are, so I can also print the types of variables. So if I take a variable name and I wrap it in the function type, Python will actually print the type of that variable for me and as it interprets it. So you can see here that name, when I print the type of it, Python says, oh, it's of type string, it thinks age is of type int, and it thinks height is of type float. And then I can do a couple of f-string prints here just as another example and say, you know what? 3 to the power of 3 is equal to, these are all strings here, just characters. And that's equal to num1, right? In the braces, which will actually calculate it. Or if we wanted to, we could put it in like this. So this would be an easy way to kind of write out, 3 to the power of 3 is equal to, that's what its value is. Someone asked, can you explain sep and end again? So I don't want you to think too heavily about this yet because I think the syntax is a little bit confusing. But basically there are like, the problem is that to explain this is a lot of little, like, what the hell is sep? Why is there an equal sign in my function call? But basically at the end of some functions, there are properties that you can set, that the function uses. In this case, you're saying separator. So sep here means the separator between name, age, and height is equal to a 2-character string with comma and then a space. And then I can also say that the end of that string, sorry, VLab's frozen on me again. I can also say that the end of that string is nothing maybe. So that's how I could like remove that that new line at the end of the string. So I can have as many arguments here as I want. Like I could have name, age, height, num1, num2. And then at the very end of all of my arguments, I can specify a couple of extra parameters, in this case, the separator and the end. You're really, really not going to print much like this. In fact, the most you'll probably use here, I think, is in some cases you will use the end parameter, but often just to specify it as nothing. That's just how you remove the new line. So that won't impact you too dramatically. People are talking about their GitLab errors for the lab. You probably haven't followed the instructions perfectly, so go have a look at those again. All right, let's try and stream through some more Python basics. We have a fair bit to get through. I was hoping to get through this by 11, but that'll be a struggle. Let's have a look at the next one. Basics 2. So this is just a little bit more on strings. In Python, strings are immutable, which means that you can't actually modify them. Once they exist, they kind of they exist forever. That's not really a fact that matters much to you, so I don't want to dwell on that right now. But what I will say is that you can do a lot more with strings in Python than you can in C. In fact, like I'll show you. Let's just print out sentence 3 times. The first time I print out sentence is after I declare it to be the string. Then what I'm going to do is I'm going to say sentence equals sentence plus more string. Think of this like in C you might do I equals I plus 1. And what that's doing is that's joining the sentence together. So we know that sentence is currently my. And when we say sentence equals sentence plus name is, we're saying sentence equals my plus name is. So let's just start with those 2 lines, right? So you get my and my name is. So this would be an easy way to actually join strings together. So if you wanted to build on a string and add more to it, you could do it like that. Or you could do it in even simpler way, which is with the same plus equal syntax that you're used to with numbers, where you could say sentence plus equals Pikachu, and now you're just kind of appending more string to the end of that. And that's how you'll get something like this. So you can build and manipulate strings substantially easier than in C. That's probably one of the biggest differences that I think students notice is in C, strings are really scary things. They're very, you have to malloc stuff sometimes, and then if you want to copy a string, you have to do string copy, and it all kind of gets a little bit over the top. But there's cool things you can do in Python too. For instance, if I want to print out the string hi 10 times, I don't need to wrap this in a for loop. I can actually just write it like this. I can actually say I want to print the string hi times by 10. And what that times by 10 will do is it will actually say, all right, I'm going to take this string and I'm going to repeat it 10 times. Let me save the file. Saving. VLab is trying to save the file. It's doing its best. Oh, it looks like Sublime's crapped its pants. Oh, okay. That wasn't VLab. So now I run it. Hi. Right? So, cool things you can do with Python. Let's look at a slightly more complicated program. We got this one here called Basics 3. Now, with Basics 3, yes, you can. The point of this little piece of code is to demonstrate. Sorry, people are asking me some questions. Yeah, you can do anything. You can say 10 times 10. And then it'll just do 10, 10, 10, 10, 10. Obviously, if you do actual 10 times actual 10, it'll just print 100. It's not going to, do anything crazy. So, what's this Basics 3 example about? It's about two key things. One is if statements, and like if, else statements, and the other one is about argc and argv. And these are two very different things compared to C. So, first thing you'll notice, this one's a little bit more complicated. In Python, there is no main function, right? It just starts at the top of your file and it just executes your code downwards. That's one big difference compared to C. Now, the other thing is that therefore there's no argv and argc in your main function, right? You don't have your int main argc, argv. And the reason for that is because you just to do anything with argv, you have to import sys. Now, what the hell is import sys? These are the equivalent lines to includes.ao.h, right? So you're used to doing hash includes.ao.h. In Python, you say import sys. So if you were to import std.ao, in Python the equivalent would be import std.ao. And sorry, I just have a tutor with an urgent query. Great. So import std.ao. So I'm going to import sys. Now sys is like std.ao, except the difference here is that I can there's lots of properties on sys, right? So one of the most important properties here is argv. So if I print sys.argv, what do I actually... Oops, wrong file. What you'll notice is that I actually get this random thing, basics3.py with 2 apostrophes and that. Now, we haven't talked about lists in Python yet, but lists in Python are pretty straightforward. So let's quickly chat about that. If I wanted to make a list in Python, I could say that my numbers equals 1, 4, 8, 10, like that. And that would be my list of numbers. It's not like C where I can add to that or remove from that if I want to. In C, it's very hard to play around with arrays. But think of this like an array. In Python, it's called lists. I wouldn't get too caught up thinking lists is something to do with linked lists. Think of it like an array that's a lot more manipulatable. But in Python, I can make an array of numbers like that. You know, there's my array of numbers. I can print out a specific number. My number's 1, my number's 2. Like this prints out the second and third element, 4 and 8. I can also add to my numbers. Like I could add, 12 to it. So like, and this is different in every language, but in Python, if you take a list and you do a dot append at the end, it'll actually add that number to the end. Sorry. So now when I print my numbers, again, you'll notice that I actually have 5 items in that list now. So list manipulation is a lot easier than in C, list or array manipulation. But I just wanted to give that very brief context because when you print sys.argv in Python, it's actually printing a list. And in fact, if I add some more parameters like Hayden sucks, like this, then I actually have a list of 3 items now, except it's 3 strings. So sys.argv is an array, just like the normal argv in C, of 3 different strings. Now you might be asking, okay, well, how do I get argc, right? Because argc is the number of those. Well, again, one big difference with a language like, compared to a language like C, is that in Python, if I get any list, I can get the length of that list by simply calling len. So if I pass the list itself into a function called len, it will return me the length of that list. So in this case, I can print the list, and then I can print the length of that list, and that's how I get 3. So there's no argv and argc in Python, there's just argv. And argv is just a list. And if you want argc, you just look how many elements are in that list. That's quite straightforward. Now, let's have a look at the rest of this code here, and we'll have a break soonish. So if I want to get argc, I simply get the length of sys.argv, right? And I'll keep this code simple. Another thing you'll notice in Python is that we actually have defined types for true and false, unlike in other languages like C. We don't have to use 1s and 0s. We don't have to hash define them anywhere. There's just true and false variables built into the language. And it has to be a capital T and a capital F. Lowercase t does not mean anything to Python. It would be like, what in God's name did you just give me? So it wants a capital T and a capital F. Most of your editors will reward you if you write the correct thing by making it a different pretty color, which is good. And you can see that if we look at, if statements in Python here, when I start off and I say empty equals true, I can then write an if statement that says if argc is greater than 0, empty equals false. Now there's a lot to unpack here. You probably understand the logic, right? Default variable, if something, variable equals something else. But a couple of key things to notice. One thing is that if statements in Python obviously differ. If this was C, we would be writing it like this with the bracket. So in what ways does this differ? Well, in one of the ways, Python does not require parentheses for its if condition. You can do it. We can do it right here if we want to. Like that. But it's not required. The other thing is in Python, we don't need braces like we would in C. And the reason for that is because in Python, white space is relevant. So what I mean by that is how the interpreter knows that this code here is meant to be executed as part of the if statement is because I put 4 spaces here. Basically a tab or an indent is the formal word for it, right? I indented this code 4 spaces in, and therefore Python goes, all right, well, everything to do if this if statement is true is executed inside of here. So I could put a print statement here too, and I could say, it's not empty, like this. And it would only execute these 2 lines of code if this if condition is true, because it's indented. And this colon here is necessary to kind of say that's the end of my if statement. So that's how an if statement looks in Python. It's pretty similar. And you can see here, if I have, what is it? Oh, indentation error. Actually, let me talk about this briefly. So I just wrote this code and Python just complained about it. The reason it complained about it is because when I added this line print here, I hit tab instead of space, and therefore what happened was that this line here is indented with a tab, and this line here is indented with spaces. Now, this in itself is not, like, this is a problem because when Python looks at this, it's like, hey, I have no idea what's going on here. Like, I don't feel comfortable deducing if these two things are actually on the same line, because remember, tabs don't have specific spaces. Now, in most editors, you can control this, like in Sublime, you can click indent using spaces so that when I click tab, it actually creates 4 spaces. But just be aware that the difference between tabs and spaces is relevant. So Zol asks, how does Python know where's the end of the if? Well, it knows it's the end of the if once it sees another line of code that matches the same indentation as the if, right? So Python goes, okay, the if is on, indentation 0. So when I next see something that's on indentation 0, I know we're at the end, right? The if statement must be over because we've hit like the same indentation level. So let me just change this code up a bit. So if we have a argv length of 1, then we set empty as true. This if statement never executes because the condition was not true. Then we print ended like this, and then we print the state of empty, which is true. If I say add another argv parameter like Hayden here, then empty set to true, argc is greater than 1. So therefore we print it's not empty. We set empty to false. We then print ended because that happens anyway, and then we print empty right at the end. Yeah, so I'm getting the usual string of people talking about VS Code auto indents, blah blah. I think that's great. I would just like flag to people, as always, that don't ever be alarmed when people tell you that IDEs do this or do that, or such and such, Pycharm will all blah blah blah. I would encourage you to kind of code in generally what you feel comfortable with, and as you get more and more comfortable, you might want to start trying out different things. Particularly when you're learning a language at the start, it can be quite useful, like for the first couple of weeks, to try and just understand it at a bare bones level. Particularly because in the real world, you can't always work in nice editors. Like sometimes you just have to connect to servers via command lines and poke code and stuff, but that's not super relevant. Let's rush through the rest of this example. Then we'll take a short break. Okay, I'm not gonna talk through the logic of this. You can go and like have a read of this in your own time. But basically I just want to highlight a couple of other key differences with Python. First one, we don't use double ands and ors, right? So you got your and or. In Python, and is and or like pipe is or. That's just a language feature distinction, which is mainly there just to make it more readable. Similarly, we don't have exclamation mark, we have not. So if I want to say if exclamation mark empty, in C I might write, if not empty, but in Python I just write not empty. Key differences being not instead of exclamation mark, and the fact that there's no brackets around it. Cups has a great question, which we'll get to in a sec. So Python, same thing. You can have else statements. You can have else if statements. One of the key differences in C, you have else if. In Python, you have elif. It's just different syntax. Don't worry. So if argc is equal to 2, we're going to do this. elif argc is equal to 3, we're going to do this. And then the indents help you understand the control flow. And then we have another if statement here, which is two conditions joined by an and. We do something and we print it. But then we have these last two important questions. First one, what the hell is parse? Okay, in C, you can write something like this. If A, do this, else do that, right? Now, sometimes you might want to leave an else statement there, but you might not want it to do anything yet. Maybe you're just trying to stub it. Maybe you've removed something temporarily. C has no problems with this because the braces are how it knows that that there's an else there. One of the problems is in Python, if you just get rid of this, like if you just have else with the colon there, then it's going to kind of freak out because it's going to be like, I went to the next line to look for something indented, but I couldn't find it. And when you run it, it'll complain, it'll say, on line 16, I expected an indented block, but you didn't give me one. Which is basically saying, can you please remove the else or put something there, like print. Now the thing is, sometimes you don't actually want to put something there. So that's what the parse variable is. Parse is just a way of saying, please acknowledge that there is something here. I'm explicitly telling you that there's nothing here. Sorry. Yeah. Now, someone also asked about spaces. Why did this work? Why did this work even though it's inconsistent spaces? That's an excellent question. So, for good style in your code, you generally want to put equal spacing everywhere. So you generally want to have 4 space indents. In this case, this one's 5. This should be 4. In this case, this one's 2. It should be 4. So we like that consistency. But just to understand how Python works, when I said before that it needs the same indenting, the formal kind of rule is that Python requires the same level of indenting in each block. And what I mean by that is, like, what's a block? Well, it's all the code typically executed like in an indent level. So here, if I have like this is a block of 3 lines of code because these are the 3 lines of code associated with the if statement. These all have to be at the same indent level. So if I don't have these at the same indent level, Python will complain. But pieces of code in different blocks don't need to be like that. As long as it's consistent within the block, then Python will accept it. So because this one's 5 indents, it's okay, because the thing is, the only reason Python needs the indents is to understand the structure of your code. It doesn't care if it's 3, 4, or 5. It's just using it as a predictable way to make sense of how the flow goes. So here it's like, well, okay, well, there's an else, and then they gave me something that's indented. Great. All right, that must be part of the else. So it doesn't really matter, but it does have to be consistent within a block. Someone asked, is parse like continue in C? Absolutely not. Python also has continue, I believe. But parse is just saying, like, parse is saying, I don't want to put any code here right now, but I still want you to execute this. There'll be more and more examples you'll see of parse. This one I know seems a bit contrived, like you're like, okay. But you'll see it come up a little bit more. So I'm just throwing some basic language syntax features at you. So just quickly, before we take a break, we have just a couple of slides to go through that'll probably take us 10-ish minutes. And then the last 2 lectures we have today are on the SDLC testing stuff and on some admin things. What we might do, if we can't get through both, we might just do a pre-record for one of them and like release it in a couple hours. So we'll see how that goes. But I don't want to rush this Python stuff. Depending on how many questions people have, these first lectures take a different amount of time. But I try not to rush this Python stuff because it's pretty critical. We could have removed the else, yes. Yes, you don't have to keep the else there, but it's like sometimes you'll want to. I don't have a great example for you off the top of my head. So it's now 11:10. Let's take a 5-minute break, and then we'll finish off the Python lecture and go from there. So yeah, sounds good. All right, let's get stuck into it. So, oh, chair broke. Ugh. Okay. Now, basics 4 is the next piece of code we wanted to look at, and this one we can get through pretty quick because I already kind of touched on lists, because I want us to talk about lists in terms of argc and argv and stuff. So, oh god, too many things have opened. Okay, just taking some notes, sorry. So we can define a list like this. Names equals Hayden, Robin, Isaac. We can append another name to that list if we want to. And if we print those names, then we will see all those names in the list, right? Just this first line here. There's our 4 names. Now, in Python, we also have while loops, just like C. And it's actually pretty straightforward. You can see this line does not look too dissimilar from C at all. In fact, I've written it like C with the extra brackets and everything. In Python, you would tend to not have the extra outside brackets. You know, you would probably tend to more likely just have something like that. So, you know, you say I equals 0 while I is less than the length of the list, which you don't need to keep track of explicitly. You can just say, you know, length of names. We're going to print names I, right? So loop through an array, print each element, I equals I plus 1. Now, that's one way you can do it in Python. The other way you can do it in Python is using what we call a for range loop, where you basically, it's a shorthand way of looping through a list when you don't care about what the index is, or the counter. And when you have a look at something like this here, notice how even though we use I, we're not interested in I. Like, we're not actually using it. Like, we're not printing it, we're not doing any sums with it. The only purpose of the I is to keep track of which element we're doing. So if you're only interested in if you're only using the I to actually get the element you're looping through, then you don't need this complicated kind of loop, right? Someone's asked, is the colon part of while? So this is a colon that's different to a semicolon, right? I'm writing out the different types here. A colon is necessary. It's just like an if statement. It tells Python that you finished the condition and you're ready to execute the block of code. So the second kind of loop here is a little bit interesting, and some of you might not have seen it before, but basically what it's saying is, I want to loop through names, the array or list. And each time I loop through it, I want to get each element in it as I loop through it, and that element that I'm getting is called name. So I'm saying for the variable name, which is going to be each element in names, and then do this loop. So if I just run this is what this code, just these 2-line for loop, executes. So it gets the names array, and it loops through every element, and each time it loops through that element, the variable name is where that value or that variable is held. So it's a very handy short way to actually loop through lists, right? Because you know, right, you don't have to deal with counters. You don't have to I plus equals 1 or plus 1 or anything like that. And yeah, so someone's asked, how would Python know what name is? Well, the way this works is Python loops through names, and each time it loops, it grabs the value it's looping over and it slaps it onto that name variable each loop. So that's why you get that. This could be anything. You could call this, like, I don't know, you could call this llama if you wanted to. It wouldn't really matter. Like that. It's just saying loop through this array, or list I should say, and each time you loop, this variable llama will hold the value of it. So, you know, if I was like hello llama, you know, it's just looping, it's just doing something, and this is the equivalent of names I, right? So it's actually very straightforward. Don't overthink it is kind of the key. Otherwise it can get confusing. So what was I going to say about that? Oh yeah, someone pointed out something. So one of the funny things about Python in particular is that Python doesn't actually have a plus plus operator. So if you try an I++, Python says invalid syntax. And the reason for this is because the language developers of Python basically had a philosophy which was, why do we need that? Like, if you have to learn what plus equals does, like plus equals 2, plus equals 3, like that is an operator that you need to learn when you learn the language. So what's the point in like teaching someone another whole operator when you can just do plus equals 1? Like that doesn't hurt anyone. That doesn't take up any extra space really. Like 2 characters, big deal. 3 characters. So if you ever want to do like a single increment, you just do plus equals 1 because, you know, like that's fine. It's completely logical. It actually makes quite a lot of sense. Yeah, so some people have asked about for loops. So in Python, you can actually do like it's not while loops versus for loops. I've probably confused a couple people here because you can actually do for loops in Python as well. Like if I wanted to do this same loop up here, I could do it another way in Python, which is for I in range 0 length names. I think that's it. That'll probably be it. Hayden, Rob, Isaac, Vivian, Hayden, Rob, Isaac, Vivian. Yeah, so it's doing it 3 times. So we've got 3 loops doing the whole the same thing here. And you can see that the for loop is a slightly more condensed version of the while loop. And there are some interesting things that are happening here with the range, which we'll come back to. But fundamentally, the point is, if you're ever looping where the only reason you're keeping track of I is to access the element, just the single element you're interested in, then you should use this for range loop down here. Right? Because this for range loop is just a lot cleaner. And it will just go through all 4 names, and then it'll finish. The while loop will, go through all 4 names as well, just like a normal while loop. So just then quickly on this for loop here. So what the range operator does, it's a very, very strange thing, I think, to get your head around at the start. But I'll just let me comment out a couple of lines here so we don't get our terminal spammed with stuff. Let me print range 0 to 10. Let's see what this gives us. Sorry, ignore a couple things here. I'm going into a depth I don't like doing so early on, but basically range 0 to 10 gives us a list of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So it gives us a list of numbers from 0 up until 1 less than 10. So what happens is when we say I want to get a range from 0 to length names, this gives us a list of 0, 1, 2, 3. And funnily enough, now you can start to see that when I say for I in range, this is actually not that different from our other kind of loop. Because what does range 0 to length names turn into? Well, it actually just turns into 0, 1, 2, 3, like that. So what I mean is that if I had a list of numbers here, I'll call them numbers equals 0, 1, 2, 3, then I could just do this. And suddenly these 2 loops start to look the same. I know I've just jumped a few steps here. God damn it, Sublime. What are you doing? But the idea is whenever you have the in, whenever you see in Python, whether it's range or whether it's list, what it's actually saying is I'm going to take a list of items and I'm going to iterate for each item in the list. It just so happens that this type of loop here, I is a number each loop, and in this type of loop here, name is a value each loop. So I'm just explaining the relationship between these two, but in reality, you're most likely to see these looking like this. This is what they'll look like. So these are 3 types of loops you're likely to interact with. Generally, you won't be writing many while loops at all. You'll probably be a lot more likely to write either this loop most commonly when you're just trying to iterate through elements, or this loop here if you need the I. Like maybe you want to print I each loop. Like if you want to print I, you can't do that with the simplified loop at all. The only time you have to use while loops in Python is when you're removing things from a list. Yeah, there's really not many cases you have to deal with while loops, so it's quite contained. Okay, tuples. This is a new concept in Python. Lists largely make sense because they're kind of like arrays in C. Tuples are kind of similar. So what is a tuple in Python? Well, at surface level, it looks like a list, except it uses parentheses instead of square brackets. Now, in reality, what is the difference between a list and a tuple? So if I say A equals 1, 2, 3, I could make a tuple that is 1, 2, 3. I could print A and I could print B. And what this would look like for us is this. It would print out a list and it would print out a tuple. I can access those in similar ways. I can get the first index 1 of it. I can do this as well. One of the biggest differences with tuples compared to lists is that tuples are read-only. So what I mean by that is I can say that A2 equals 9 here, just like I can in C, and it will change the value of 2 here to 9. But if I try and say B2 equals 9, I get an error. The tuple object does not support item assignment. Basically, you can't override elements. Now, yeah, exactly. So lists are mutable. The elements in lists are mutable, and the elements in tuples are not mutable. So in practice, though, the main reason that we use tuples for things is because tuples are kind of a bit more accepted of the logical way to store collections of items in a list-like structure where, how would I say it? Where it's like a list is kind of a fairly straightforward type, right? It's like you have this type of numbers and it's going to grow and be smaller, and like maybe it's 4, maybe it'll be 5, it might be 6, 7, 8, 9, 10. You know, it tends to be lists of names, lists of students, lists of numbers. Tuples tend to be more when you're actually trying to just group a set of things that you know how big they are, right? So a good example, which I have in this piece of code here, is a point in space, x and y. So in C, you might store a tuple like a struct. You might store a point like a struct where you say there's an x and a y property, but you know, sometimes you might just want a really simple thing where you say, you know what, I just really want my point to be a list of x and y. I don't want it to be modifiable. I just want to store these 2 points and I just want to print them out. And yeah, Praf has already asked and been answered. Tuples are parentheses, lists are square brackets. And this gives me 5 and 6 and I can print out point. You know, if I want to add a z item here, I can just add it like that. Now I just have 3 elements in my tuple. So rather than needing to pass x, y, and z into a function, I can just pass point, a little bit like a struct. Even though tuples are like arrays and lists, you're going to sometimes use them in places you would have used a struct in C. One totally new idea in Python, though, is this concept of destructuring. Now, the concept of destructuring is such that you can create a tuple by saying tuple equals a collection of items, right? A list of items. Inversely, you can assign a series of variables directly to a tuple. So if you actually look at lines 3 and 4, or 4 and 5, and then 7 and 8, these are actually the same processes, but in reverse. And this is a very, very useful language feature that you don't find in I think some languages like Java and stuff, where if you have a tuple like 3 coordinates, rather than like, okay, this is how you would normally do it, right? I've got a point x, y, z. If I want to extract those points out, you know, maybe I'm calling them in a function, right? So let's tie in a little bit of function learning here as well. In a sec. We'll do that in a sec. Normally what I'd have to do is I'd have to say, well, a equals 0.10, b equals 0.1, c equals 0.2. And then if I wanted to print them out, I'd say, you know, print a, b, c like this. That makes sense. You know, point is a list, like a tuple or a list. It's a read-only list or a tuple. And I want to extract 0.0, 0.1, and 0.2 into those variables. You know, but it's a little bit more verbose, like it's a lot to write. So instead here, we can actually just say a, b, c equals point. Now I'm going to put a, b, and c in brackets, even though it's not required, because you can actually then see the symmetry here, where like you say point is equal to a tuple of 3 items, and now you say, you know what, these 3 variables I actually want to be equal to point. In terms of destructure, like point is a structure of 3 elements. Destructure it, take them all out and slot them into my variables. So destructure point and put each element in A, like the first element in A, the second element in B, the third element in C, and then I want to print them out. Like that. Now, just on the topic of functions, I can make my own functions in someone says, would point equal this? Yeah, so, I mean, if you said point equals empty tuple, then I mean it's just like, oh, sorry, I'm boring myself. It just says like it's an empty list, basically. It's a read-only empty list. You wouldn't really do this though, because it's read-only, it wouldn't give you a great deal of use. So Tenet's asked an excellent question, which is like, can we only extract 2? Let's try that out. So I've got a point here which is made up of 3 elements, a tuple made up of 3 elements, and I want to just extract the first 2. No. So you can't do this, sadly. So in Python, if you either kind of extract them all or none of them. If you don't want to extract them all, generally you would then just revert to like the basic you know, thing here. There's some other things you can do that are kind of sneaky, but you know, let's just start off with this. So at the moment, you kind of need to get all the elements. So A, B, C. Now this leads to a good question I have, which is, like, why would we do this? And the answer is quite simple. So in Python, you can make functions if you'd like to. And we'll make a function down here. I will call it print name. And this function will take in a name. Now, it's a little bit different to a C function in the sense that it just looks different. Like most C functions start with like int or double or void or char or something. Because Python is loosely typed, it all just starts with def, which I believe means define. And then you give it a function name and the parameters just like C, except then instead of the braces, you just have the colon. So it is very similar to C. Now, if I want to use that function, I can also just like in C use it. I could say, I want to, maybe not print. I might have this return something. So you really don't need much new knowledge here. You can piggyback off most of the programming you know. I could say I could say print name Hayden. And what this will do is this will call the function print name with my name, and then it will return hello and then my name, and it will print it. Hello Hayden. So functions, very similar. That's why we don't talk about them a ton, because they're not too different from what you're used to in C. But this might help you also understand why we like this destructuring thing, because in reality, you're not just going to make a point and then destructure it straight away. In reality, what you might be doing is, say, having a variable here in print name called p, and I might call this print point. let's rename this to print point. And inside of this, I'll do my destructuring. A, B, C equals point, and then I will return an F string of A, B, C, like this. I'm going to just clean up my code a little bit here. And then I will change my code around to say print point, point. Okay, I just did a whole bunch of code changes, and we'll talk through them. And first question, Luke's asked, can we only use the function after where it's written? Yes, I believe that's true. We'll probably get an error here. Yep, print point is not defined. Generally, from a style perspective, you're always going to define your functions at the top of the file. Usually it's after your imports. This is all written in the style guide. It's after your imports, but it's before the rest of your code. And you can see that I'm calling point here and passing it into this print point function. And we're passing in a point, which is a tuple of 3 items, and it is destructuring those 3 items and then printing them. So this might be a way that you might create a point and then pass it into a function and actually print something. So let's have a look at some more questions. Can the function's parameters be different data types depending on how it's called? Yes. So this is the downside of loosely typed languages. It doesn't give a great deal of confidence when it comes to what types variables are. Absolutely not. And that's not a great thing because like when you look at P, you're like, oh, what's P? I don't know. You have to go and read more source code. It doesn't just say something, you know, like struct point P. The other downside is that there's no compile time restrictions if you like passing in the wrong thing. So I could try and pass in the string A and Python will just crap its pants. What? Oh, sure. This is some weird global variable stuff. I wrote that function wrong, sorry. Okay, so you can see here that Python actually fails, I believe, on runtime here because we tried to pass a string into our print point function. And it's like, yo, there are not enough values to unpack. You told me that you want to destructure 3 values here, but you gave me a goddamn string, which has an A in it. And I don't know what to do with that. So Python will pick up on these issues, but the loosely typed does make it a little bit challenging because you have to get these things right. The variable P is just a function parameter. I could call this like input point if I wanted to. It doesn't really matter. It's just like other languages. It's just a parameter for a function. Catherine says, is this same concept as arrays being pointers to data and therefore can move in and out of functions without losing data? Yes. So it's also quite similar to C in the sense that a lot of your primitive types like numbers, most types are passed in by reference, and we can try that out here. So let's say make a variable called number equals 5. Now we'll make a function called increase, which will take in an n, and what it will do is it will increase n by 1. Okay, and now let's print increase number. So if you just look at this little section of code here, we set number to be 5. I mean, I don't need to define these in this order. We set a number to be 5, and then we print the result. Sorry, this is why I try not to write too much ad hoc code. But it's a good question, Catherine. We have a number 5. We call the function increase, where we pass number into it, and then we print number. And let's see if increase actually increases it. Right, so this goes back to that whole concept of pass by value, pass by reference, or, you know, pass by pointer. Five. So, similar to C, when you pass basic types like ints or doubles or chars into a function, it will pass it by copy, right? It will copy it in. So 5 was copied into this function, and then it incremented a local variable to this function, which nothing was ever done with there. However, when you get to more complex data types, like lists, the story's a little bit different, right? And in that case, if I have, like, say, my list here, which, might have 1, 2, 3 in it, and then I, increase my list like this, and then I print my list at the end, and what increased list does is it, say, adds another element to the list, like 4, right? So follow this logic. I've got a list with 3 elements. I pass that list into an increase function, which takes that list, I might just call it L, and it adds a 4th element to it, which is the number 4. And then I print my list. What happens in this case? Oh, I need a pen, sorry. Dot append. My bad. What happens in this case is it does actually modify the list, because most of these complex data structures, like lists, like tuples, they are passed by value. Sorry, passed by reference. So like a pointer to them is kind of passed in there. So just to tie off the tuples thing here, hopefully that makes sense with tuples. They behave like lists, except they're you can't modify the elements. They're read-only. You tend to use them when you want to basically have a list of elements that is like a fixed size. It's a little collection of things. It's not an expandable list. It's when you have like a set collection of things that you just want to structure in a list. Yes, Yurchand, a list is an object in the eyes of Python. You can also destructure a list. Caps has a great question, where if I go back to this example here, I can actually destructure that list as well if I want to. I could say ABC equals list, and I could print ABC like that. Lists and tuples behave really similarly. So they're really quite interchangeable in many, many ways. Ken's asked, will this be covered in the lab exercises? So the lab exercises are pretty light on Python this week, but the next few weeks there's a lot of different exercises with Python. The thing is, again, because this language is so much bigger than C, we can't really we can't give you an exercises on lists and an exercises on tuples and exercises on strings and exercise on like powers and argc, because there's so much to it. So what we're trying to do in a lecture like this is give you like a little bit of a taste of all these different elements, because particularly in your project, when you start working with your team in your project, you're going to come across 100 different scenarios where you'll need to be like, I'm going to Google this, and we're just trying to make enough familiar to you. I mean, you can obviously watch this lecture again and take it a little bit slower as well. When we destructure lists or tuples, does that mean we can no longer use them? No, you can use them. It's not like you're breaking them down. You're kind of taking a copy of them. That's a really great question, Panda Guy. So it's taking a copy of them. You're not destroying them. You're just taking a copy of them. Yeah, exactly. So Catherine summed it up too. The big difference between tuples, the only difference as far as I'm aware between tuples and lists, is that tuples have read-only items. So you can't modify it. You can't change what's inside it. But it's not just about like the functional difference. My point is also that people tend to use tuples when you're just trying to have a collection of items that you generally know is roughly the same size. So it's kind of like structs in some conceptual senses there, that structs are like, yeah, I'm going to have a data structure with these 4 things in it. So typically people would not store like 2 items in a list if it's like an X and Y coordinate, because a list implies a certain amount of elasticity. So that's why we tend to use tuples in those instances. Okay, I'm not gonna talk about that last piece here because that's, I don't think, super critical. the last little bit of Python I want to chat about before we talk about the project briefly is string slicing. Yes, to the people asking in the chat, if you returned n, then you would have gotten 6 before. It's the exact same principle as C and 1511. When I'm not teaching you anything new here, I'm just demonstrating the same stuff you know in another language. Okay, so I just want to talk basic 6.py very, very briefly. Last Python concept about what was F for? Cherry Blossom. Back in Basics 1, I talked about F strings, which you can go and have a look at. You can go watch that part again. Okay, so the last thing I want to talk about in Python, because this will come up probably for some of you in the labs this week, is this idea of list slicing, or string slicing. So if I have a list, and I'll call it chars, and it's just A, B, C, D, and E. If I print that list, I will get all of those elements, right? A, B, C, D, E. If I want to get the first element, I do 0. If I want to get the last element, I do 4, right? Now, there's a couple of extra cool things that we can do with Python. The first one is, and I think, where was this? I swear, did I? Oh, we talk about this a little bit next week, in dictionaries, I think. Yep, we talk about this a little bit next week, but I'll just give you a taster of it at the moment. You can actually also get the last element of a list using a negative index. This is where your array logic differs compared to C. So in Python, if you want to get the last element of a list, you can actually just pass in -1. And the way to think about -1 is that if you kind of start off at 0, if you go to -1, it's kind of like wrapping around back to the end. So that is really useful to get the last element of a list. You can do more with negative indexes, but that's kind of just what we'll start with. So, negative indexes is one whole topic that, you can read about if you'd like. And then the second thing I want to quickly mention is the idea of array slicing. Now, this is extremely useful, and this can get very, very complex, and there's 100 different rules for this, but I just want to show you the basic ones. So if you had a list or an array in C that was 5 elements long, and I asked you to get me the first 3 elements, you would typically kind of have to, you'd make a new list and you would loop through it with a counter up to 3, and then you would, do it that way. But with Python, you can actually do things much simpler. If I want to get the first 3 elements of my chars array, I can put 2 indexes between a colon like this. Now, whenever there's a colon in the index part, that now becomes a slice. And what that's saying is I want to get all the elements from index 0 up to but not including index 4. Right? So let's try a different number. 0 to 2. How many elements is this going to produce for us? I'll print it out so you can start to see it. So pay attention to the difference between these things here, right? When you do indexing a list with one element, right? Just one element. What you get left with is you get left with a single item, right? If you have a list of chars, you get left with a char. When you do array slicing, it takes a list of chars and it produces a list of chars. It just happens to be a subset of that list. So you can see here that when I've said 0 to 2, what this actually means is I want to get the 0 element and the 1 element, but not the 2, because it goes up to but does not include that second number. Does that make sense? So it says 0, 1, but not 2. So it doesn't include that number. It's everything up to but not including that. So this is how I can say get the first 3 elements in my list or array. So have a look at all the differences here. I can slice different parts of this array, from the 0th one to the first, but not including it. Notice how that's different from char0, because char0 just returns us A, whereas char0 to 1 returns us a list with just A in it. So remember how I said that array slicing takes a list of elements and returns you a list of elements, as opposed to just an element itself. You can do more with array slicing. You can do chars 2 to 4 if you want, to get some elements in the middle, like that. You could do 3 to 5 to get other elements in the middle. Someone asked what happens if you slice 0 to 0. You can try most of this out yourself. You get an empty list because there's nothing there. People have said what happens if you do it out of bounds. Python will... Oh, I thought it would yell at you. Okay. It doesn't yell at you. It just is like, okay, sure. I'm just going to ignore that request. So Python is a lot more memory safe than a language like C. Anyway, we can talk more about this next week when we talk about other types of data structures. But I just wanted to mention that now because I think it's useful for your first lab. So, yes, array slicing. There's a lot to it. There's a lot of fancy things you can do. You can go from like -2 to -4. I'm not going to get into that now. Play around with it in your own time. So that's pretty much it. That was a very long intro to Python. But yeah, hopefully we covered pretty much all of the basics. There is a lot more Python next week as well, but this is kind of like the basics to do many, many things in Python.